Right. Let's talk about the gravitational field in orbit. So first, let's start talking about the gravitational field strength, which is a force that keeps any object in orbit to another object. So in our solar system, it can be a planet in orbit around the sun, and this is due to the presence of the gravitational attraction between the sun and that planet. Okay, this is related to the mass of the sun, and the sun contains the most amount of mass in our solar system, and this explains why most of the planets that are in our solar system orbit the sun. This gravitational field strength is dependent on two things. The first one is the mass of the planet, and also the distance of the planet from the sun. As the distance increases, then we know that the gravitational pull will decrease or weakens. Yeah? Alright, so let's move on to the second part. We know that gravitational strength is present on planets as well. So it has a strength that keeps the buildings or objects firmly grounded. So as we know on our Earth, mountains, buildings are grounded due to the presence of gravitational field. And also objects can fall due to the gravity, right? The gravitational pull to the center of the Earth. And if we launch satellites or spaceships, we can keep them into orbit around our Earth due to the presence of the gravitational field, right? Now this gravitational field is different from different planets in our solar system. So the sun has the largest mass, and hence it has the largest gravitational field strength or the gravitational pull. And then compared down to Jupiter, which is lesser in gravitational field strength, but its mass is still quite high, and all the way to what we know as our planet, which is quite small, but has the G force, which is 9.8 Newton per kg. Now let's talk about the gravitational pull and its effect on orbital motion. So we know that orbits usually are created because of this gravitational pull. So some bodies orbit others, like as we know that the planets orbit the sun or the moons orbit planets. So let's talk about planets first. Planets usually orbit the sun, and then the moons would orbit their neighboring planet. Comets orbit the sun as well in an elliptical orbit, and asteroids, they also orbit the sun in the asteroid belt. Yeah. So if we launch artificial satellites, they will orbit the planet or the object that we launched them in the solar system, nearby them. And if we talk about the sun gravitational field and dependency on the distance or relationship to the distance, so in order to keep an object in a circular path, we need to have centripetal forces to pull the object to the center of rotation. So this is done by using gravity, where everything is orbiting the sun is pulled by gravity, and then the strength of this gravitational pull would decrease if the object is placed further away from the sun. So this planet right here will have a weaker gravitational pull when compared to an object that is relatively closer to the sun, nearer to the center. This relationship is defined as the centripetal force is proportional to the orbital speed. Okay, so that means that the further the planet is, the planet will have a smaller orbital speed, and this equates to a larger or longer orbital duration. So of course the planet furthest away from the sun will cover a large distance and will have the lowest orbital speed. Now let's talk about comets briefly. So comets also have this relationship in their elliptical motion or elliptical orbits. So as you can see here, they have this elliptical orbit around the sun. And as their distance from the sun or radial distance increase, we know that they will have slower orbital speed because of their low gravitational pull or lower gravitational field strength pulling them towards the center of rotation. And as they approach the sun, the radial distance reduce, and then we know that they will reach the fastest point around this part here where they are closer to the sun. And now we can say that there is a conservation of energy when we talk about orbital motion and also the gravitational pull. So in order for object to stay in elliptical orbit, such as comet, they need to be constantly changing their speed, and the speed will affect the energy, so the energy must be conserved. Now the conservation of energy will be decided based on the conversion of gravitational field, or gravitational potential energy. As the comet approaches the sun, we know that the gravitational pull will be highest, which means that it will lose some gravitational potential energy and gain a lot of kinetic energy in the form of speeding up. Yeah, and then this can create a slingshot effect where the comet can exit the orbital motion and be slingshotted outside of its orbit. As the comet is moving away from the sun, we know that it will gain a lot of gravitational potential energy and lose a lot of kinetic energy in form of slowing down, and then it will stay in orbit and move towards the sun in the same orbital motion. So this is how we call the stable orbit can be formed. Yes.